Well, in this video, we want to look at the graph of the tangent. Okay. Now, the tangent, as you can see, has these periodic asymptotes. How do we get those? Well, remember, the tangent is defined as the sine over the cosine. The sine over the cosine. So, okay, if I were to momentarily place in here the graph y equals the cosine of x, okay, then we would see, okay, that when we're looking at the graph of the cosine, okay, we are seeing where the cosine zeroes out, okay, and where the cosine zeroes out, or that is when the cosine goes to 0, right there, pi over 2, negative pi over 2, 3 pi over 2, okay, division by 0, that is sine over cosine, gives us, okay, an undefined value or an asymptote. So therefore, the graph of the tangent comes right out of the sine over the cosine, and we'll have the values where the cosine is equal to 0, we'll have the asymptotes. So therefore, in defining what the domain of the cosine of the tangent is, we have to say that the tangent is all values except those multiples of pi over 2, or we could say pi over 2 plus pi k, pi over 2 plus pi k, since the period of the tangent, as you can see, is simply pi, okay? So the period being pi, we say, well, what happens if we change the period? With sine and cosine, the new period was 2 pi divided by b. Here, if b is 1/2, okay, then pi divided by 1/2 is 2 pi, and there you can see the graph of the tangent is now with a period of 2 pi, when this is graphed as y equals tangent of 2x, okay? Go back to our value of 1, all right? The other things that you can control with the tangent function, much like with a sine and cosine function, are a, b, c, and d, okay? A, b, c, and d. However, when sine and cosine, a was said to govern the amplitude. Well, a will change things here, as you can see, okay? But tangent really has no amplitude, because amplitude, as previously defined, was the largest value minus the smallest value divided by 2. Well, the largest value is, okay, infinity. The smallest value is negative infinity, so we can't get any value out of that, all right? One thing you note that a will control, okay, it will control the rate at which the graph approaches the asymptotes of pi over 2 and all those pi over 2 plus k pi values. Now, of course, when the values are smaller, okay, like 0.5 here, you see it gets a little flatter, all right? When the values are greater, okay, it gets stretched out more, if you will, stretched out as if you're pulling at the ends. When it's negative, it's flipped over the axes, okay? So tangent function, again, phase shifts, move it left or right, move it left or right, okay, just as you did. Phase shift is again going to be c over b, okay, so phase shift of 1 with, let's say, a b value of 2, okay, will invoke a phase of 1 over 2, is a shift of 1/2 unit to the left with the graph there, okay? So we'll take it back to the regular values, and now of course the d will move it up or down, move it up or down, move it up or down, okay? We might as well take a look at the cotangent while we're here. All I have to do is change that to cotangent, okay? And the cotangent, and we'll take a look at that with the unadjusted values. So we'll slide this back to 0. Okay. Now, of course, the cotangent, as you can see, has asymptotes at other locations, and mainly because the cotangent is defined as what? Well, it's defined as the cosine over the sine. Okay, the cosine over the sine. So if I were to look at the sine graph, okay, then where the sine graph zeroes out, we have the asymptotes for the graph of the cotangent. where the sine zeroes out, which is all multiples of pi. So you have the 0, pi, 2 pi. In short, we could just say pi k. So in determining the domain of the cotangent, we would say it's all values except pi k values, and that would be, of course, because it's defined cotangent as the cosine over the sine. All right. And again, the whole host of other things. The period is pi. The period is pi. It is defined for all values except for those multiples of pi. The range is negative to positive infinity. The period is pi. That the b value offsets it to pi divided by b. So now we have, with this b value of 2, we have the cotangent of 2x, which is now the entire graph is stretched out in half a pi units. Okay. Same thing. Control slides up or down. Okay. No amplitude change, but you can change, like pulling on the graph like that. Okay. The a value goes negative is, of course, flipping across the axes. All right. Flipping across the axes. All right, so there is tangent and cotangent, okay, brought to you by Desmos, and we have some worksheets for you. Mainly, if you can envision these graphs, then it'll help you in answering some of the questions about where the intercepts of the functions are, okay, where are the asymptotes, and that kind of stuff. All right, so there you have it with the tangent and the cotangent.